Okay, so we are starting afresh with a new concept of the derivative, a new understanding. So I'm going to draw our triangle. We have x value, and this is going to represent our height, or our y. Okay, so we have this equation now. The area equals negative x cubed plus 75x. I'm going to show you now how to find the derivative. Now that we have an understanding, a conceptual understanding of it, we can really work on it. So we're going to do this by hand. A prime, it's a good start, equals. Now this is important that we treat each of these separately. So we have this x cubed, negative x cubed, and we're going to treat it separately. And for this, we're using the power rule. Negative x cubed, since it's an exponent to a power, always uses the power rule. And I'll show you what it is. It's a very easy concept. The power rule states that if we're taking the derivative of this, of an exponent to a power, of a variable to a power, then what we first do is take the exponent value and multiply it by the coefficient, which is, in this case, negative 1. So, good start. Negative 3, drop down the x. And then the next step is we take this exponent, the original exponent, and just subtract 1. And put it up there. Negative 3x squared. There we go. That's the derivative of negative x cubed. And now, we're going to treat this as another section, 75x. And the derivative of 75x is just 75. And I'll show you why. So say we have the derivative, or the graph of 75x. Looks something like that. Now, this slope is constant throughout. So say the slope equals 75. Since it's always 75, the derivative would be the same throughout. So it would look something like this at the point 75. So that is why 75x equals 75. We just take away the x. Alright. Back to business. Now that we have our derivative, we are in very good shape. So now we need to plug in 0 for the a prime value. So 0 equals negative 3x squared plus 75. And remember that we're doing this because we're looking to find this x value when the y value equals 0, because that will be our maximum x value. So now we just solve algebraically. Subtract 75 from both sides equals negative 3x squared. Divide by negative 3 on both sides. This is turning out very well for us. 25 equals x squared. Take the root of both sides. X equals 5. There we go. This is our maximum value for x. This is our optimal value. This is what we've been looking for. Now, if we plug this in, we can find in the base that the base equals 2x, which equals 10. There we go. You can see the light at the end of the tunnel. We're almost there. Now, I'm going to start a new slide, and with this information, with this x value, we're going to find the y value. And you might already understand how to do this, or know how to do this, because we have, if you look back, functions that incorporate both. Okay, now that we have our x value, which is 5, we can now solve for y. And if we look back, the best place that we can see to plug x and y into the same equation and get one of them is our function equation. Y equals negative x squared plus 75, the original. So we're going back. Plugging x in, y equals negative 5 squared plus 75. Y equals negative 25 plus 75. Y ends up equaling 50. Great. Now that we have our y value, we are pretty much set. Now we know that this value in the middle is going to be 50. That is our height value. So now that we have the parameters of the triangle, we're pretty much done. But the last part we need to do is just find out what the total area of the triangle is, what the optimal area of the triangle is with these parameters. Now, if we're going to do this, then we need to plug it in to an area equation. So, area of a triangle equals 1/2 base times height. So in our case, the area of this triangle equals 1/2 times 2, remember, because we have two x's, 1 and then 2. 2 times 5, which is our x value, times 50, which is our y value. If we do this out, the area of our triangle equals 10 times 50, so 500 times 1/2, 250 miles squared. Great. This is the area in which the pigs are going to live in their triangle. This area right here. If we relate it back to the story, we will say that the pigs, this pig right here, this pig right here, and this pig right here, will live a certain distance from each other. These two pigs will live 10 miles from each other, and these two pigs will live a certain value. We'll use the Pythagorean theorem coming up next to determine that value, but this value in the middle now we know is 50. So this was a nice little problem to get us warmed up with optimization, and I hope you liked it. This takes us into the next part of our story.
After 2 weeks, each of the 3 pigs was settled in his respective home. John, being an industrialist, built his house of brick. James, being an environmentalist, built his house from sticks. Dave, being a bum, built his house from hay. One day, the 3 pigs disregarded their mother's warning and left the gate open in the stone wall. Soon after, the big bad wolf arrived and entered the pigs' land. The first house the wolf came upon was Dave's. When he arrived, the wolf said, let me in, or I'll huff and I'll puff till I blow your house in." "Not by the hair on my chinny chin chin," said Dave. The big bad wolf huffed, and he puffed, and he blew the straw house in with ease. Alas, the big bad wolf made poor Dave into a BLT and made a snack out of him. Feeling sleepy, the big bad wolf decided to take a nap and wait until morning to continue on his way to James's house. James, knowing that the big bad wolf was coming and that he was known to have a peaky stomach, in order to calculate whether the wolf would be able to eat James, he formulated a related rates problem, incorporating the speed of the big bad wolf's digestion and his velocity. This calculates when the big bad wolf would arrive at James' house. If Dave had not been fully digested, then the big bad wolf would not eat James.
To solve for the rate at which the wolf is digesting the pig, we can use this equation d equals x squared. Now this tells us the rate at which the wolf is digesting the pig, and on a graph it looks like this. The y-axis being d, which equals the digestion, and the x equaling his position. Now, if we wanted to find out the rate at which it's digesting after 10 miles when the wolf will get to the pig's house, we want to take the derivative with respect to time. So we d dt each side, And so we get on the left side d dt, which equals 2x, which is the power rule, times dx dt. Now, the x here represents his position in miles, and this dx dt represents the rate at which the wolf is walking, which is in miles per hour. And this dd dt represents the rate of which the wolf is digesting, which is in calories per hour. Now, if we want to find when the wolf digests the pig after 10 miles, which is when the wolf would reach the pig's house, we plug 10 for x, which is miles, the distance that the wolf has to travel, and 2 for dxct, meaning 2 miles per hour, which the rate the wolf is walking. So if we multiply this out, we get dd dt equals 40. 40 calories per hour the wolf is now burning.
If the wolf is digesting less than 30 calories an hour, then James, the second pig, will not be eaten because the wolf will not have room in his stomach. But since the metabolic rate is above 30 calories an hour, then James will be eaten after the wolf has gone 10 miles because the wolf will have room and will have digested the first pig.